Again, we're going to begin adding and subtracting equations. In order to add and subtract equations, we're going to isolate the variable or the unknown. And we use the inverse operation to isolate the variable, okay? So now what I'm going to do is we're going to do a couple of examples. Let's look at the following. Let's say we have the following. W plus 15 equals 22. So in this equation, the variable is W. This is what we're looking for. So we're looking for the value of the variable. So the first thing we need to do is isolate the variable by using the opposite operation. Here I can split the equation. And then I need to get rid of this 15. So I need to use the inverse operation of addition. And that's going to be 15 minus 15. Whatever I do to one side of the equation, I'm going to do to the other side of the equation. So that's 22 minus 15. Okay? So now here I'm left with W on the left side, and once I subtract, that's going to give us 7. W equals 7. And the way that we can check is substitute 7 for W. So if I write 7 plus 15, that's going to equal 22. Because 7 equals the W, okay? All right. Let's look at another example. So we have M minus 24. That's going to equal 15. M minus 24 is going to equal 15. So now I can split the equation, because remember, one side of the equation must equal the other side. Okay? So now I'm subtracting 24 here. So if I'm subtracting 24 here, I need to use the inverse operation and add 24 to both sides. Okay? If we're subtracting here, we need to add. Once we do this operation, we're going to be left with M. M is going to equal, well, when we add 15 to 24, 5 plus 4 equals 9. 1 plus 2 is 3. So that means M is going to equal 39. Of course, we can check this by substituting the value that represents M and solving. So that means instead of M, I'm going to write 39 minus 24. And of course, 9 minus 4 equals 5. And then 3 minus 2 equals 1. So this is equivalent to this problem, okay? Are there any questions so far? Are there any questions so far?
No.
All right, so now let's look at the following problem. I'm going to leave the last one here up as an example or reference. So we have 6 plus y equals 25 and 5/10. 6 plus y equals 25 and 5/10. So of course the first thing I need to do is isolate the variable. Here the variable is y. So first I'm going to split the equation. And of course, this is a positive 6. So in order to get rid of this positive 6, I need to do what? I need to subtract 6 from both sides. And here I need to make sure that I line up this 6 in the correct place value. Nope, that's not a 5, that's a 0. Sorry. All right, so now we're left with y on the left side. And y is going to equal, when we subtract the following information, of course, this is 5. We regroup. This is going to be 9. Okay, so now here, oh, and the 1, I'm sorry. All right, here we go. So now we have y equals 19 and 5/10. Of course, we can check this by adding and substituting y for 19 and 5/10. So that's 6 plus 19 and 5/10. Of course, you have your 5 decimal point. 9 plus 6 is 15. Drop your 5, raise your 1, and then you have 1 plus 1, that is 2. So this is the same thing as this one. So this just makes sure, this just tells us that y equals 19 and 5/10 because we got the total here. Okay? All right, let's look at the following and then we'll move on to modeling. So let's say we have the following. X minus 2 and 25/100 equals 15 and 5/10. Okay. So, of course, we're going to split the equation. And we're looking to isolate the variable x. Can someone unmute their mic and tell us how we isolate the variable?
Adding.
Adding. So we're going to add what to both sides?
2 and 25/10.
Very good. Thank you guys for your participation. 2 and 25/100 on both sides. And of course, we're going to add a placeholder 0. So here, we're left with x, and that's going to equal, and when we find the sum of these two values, of course, this is 5, this is 7. Bring down your decimal point. This is 7, and this is 1. Okay? And of course, we can check this by substituting 17 and 75/100 with the x. So here I'm going to do that to the side. 17 and 75/100 minus 2 and 25/100. Of course, 5 and 5 is 0. 7 minus 2 is 5. Bring down the decimal point. 7 minus 2 is 5. And then we have 1. So this value here equals this value. Okay? Are there any questions so far?
No.
All right. So now we're going to move on to modeling. And modeling works the same way. Modeling works the same way. Here we go. So let's say we have the following. So this represents our variable. This represents our variable. And then we're going to have the following. Okay? So now, we have two sides of the equation. Each one of these represents a positive 1. So can someone unmute their mic and tell us what equation is represented by this model? Of course, we know our variable is m. And what else do we have?
5
m plus 5 equals
9.
9. Very good. M plus 5, 1, 2, 3, 4, 5 equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So now we just do the same thing. Isolate the variable. How will we isolate the variable here?
Subtraction.
Subtract. What are we going to subtract from both sides?
5.
5. Very good. Thank you, guys. Thank you, guys. And then once we subtract 5 from both sides, we're going to have m equals what value?
3.
4. Okay. All right. So now, of course, we can check 4 plus 5 equals 9. And if we wanted to put this on a number line, it would be a single dot, single shaded dot. And of course, the value of m equals 4. Okay? Pretty simple, right? All right, here we go. So let's look at another example, and then I'm gonna, we did too many of those examples. All right, so we're gonna do one more modeling, and then I'm gonna let you guys go, okay? Here we go. Let's say we have the following, and I'm gonna use a different shape for our variable. All right, so now let's look at this problem. Can someone tell me what they think the equation is that represents this model? W minus 9 equals what type of 3? Negative 3. Okay? So now, I don't know why I wrote that so far. Let me rewrite this. W minus 9 equals negative 3. Now, if we follow our integer rules, we can rewrite this as W plus a negative 9 equals a negative 3. Okay? So now here, of course, we can split the equation. And we'll have W here. And of course, that's going to equal whatever we get from this side. So now, if we wanted to get rid of this negative 9, how will we get rid of this negative 9?
Put a positive 9.
Positive 9. And then we're going to do the same thing to both sides. Okay? So now, of course, we have integer rules, different signs. We subtract the sign of the larger absolute value. So, of course, W should equal what value? Positive 6. Okay? And of course, we can check a positive 6 minus 9 equals a negative 3. We can rewrite this as 6 plus a negative 9 equals negative 3. And of course here, 9 minus 6 is going to equal 3. And since 9 has the greater absolute value, our answer is going to be negative. If I wanted to put this on a number line, of course, it's going to be a shaded closed circle or closed dot. And what's the value that should be here? under this dot, under this point on the number line?
-9.
Not -9. What was our W?
6.
6. Remember, whatever your variable is, when we're graphing it on a number line, that's going to be what that is. Okay? That's not a negative. There we go. So W equals 6. So if it's on a number line, it's just going to be 6. Similar to how it was here. M equals 4. So if it's on a number line, it's going to equal 4. And